The next two lessons, 23 and 24, we're actually combining those into one video. And the reason is because they're so closely related. And as you can see, the topic is called Solving Equations Part 1, because there's actually going to be another part to this, which involve a little bit more difficult equations. Let's take a look at the first part of this lesson. Now, the first part of this lesson is called inverse operations, and something that everyone needs to understand with solving equations is to understand what the inverse operations mean or do. So, for example, if I have addition, the opposite of addition is subtraction, and vice versa. If I were subtracting, the opposite or inverse operation of subtraction is addition. So addition and subtraction are inverse operations of one another. Now you can kind of see where this is going with multiplication. The inverse operation or opposite operation of multiplication is division, and vice versa. The opposite or inverse operation of division is multiplication. So as we're going through these examples, we want to keep this in mind. Now there's something else that I really want to stress with this. You have had equations like x plus 2 is equal to 7. And you know what? This is a pretty easy equation to solve. You can do this mentally. So in other words, you might ask yourself, well, let's see, what number plus 2 would give me 7? And we would know that x would have to be equal to 5. Again, a very easy equation that you can easily do mentally. Now, you're going to have some of these in this lesson, and you might be saying, well, why are we going through all this other stuff? Why can't we just keep it simple and use the mental math part of this? Well, because the reason that the examples that I'm going to provide you with in a little bit, we start off easy with those. Okay, we start off very basic, so it's easy to begin to learn or review how to solve equations. And I guess the key point here is they do get harder and they do get much more challenging. And if you don't understand the concept and the procedure with inverse operations and what we do with these examples, it's going to be very difficult. All right, let's take a look at example 1. Now in example 1, they want us to solve the equation x plus 5 equals 17. Now, as I said before, very basic equation. Yes, we could do it mentally, but we're starting to get a procedure down, because you don't want to get to these equations in the future and all of a sudden be totally lost. So what we're going to do here is we're going to solve this, and we're going to solve this through the concept of inverse operations. So the first thing I'm going to look at is I'm going to look at x, and I'm going to ask myself, what are they doing to x? What's going on the left side of this equation? What are they doing to x? And as you can plainly see, they are adding 5 to x. They're adding 5. So up here, I'm just going to write down adding 5. Now, what's the inverse operation, or what's the opposite of addition? Well, it's subtraction. So what we're going to do to solve this equation is we're going to subtract 5 from both sides of the equation. And the reason that you have to do it on both sides of the equation, you might compare this to maybe a balance, a science balance that you might have in chemistry or some science class. So, for example, in that science balance, if you have 5 grams on this side and 5 grams on this side, if I take away 2 grams on this side, how do I keep it balanced? Well, I better take away 2 on this side also. You can liken an equation to a science balance. And the key thing, and you're going to hear me say this many a time in class, is what you do to one side, you have to do to the other. And that's understanding the concept of solving equations. So the first thing that we're going to do here is, again, we're going to subtract 5 from both sides. Why do we do this? Again, understand why we do this. Let's see, if we add, look on the left side. If we add 5 to one side and then subtract 5, well, those are going to cancel out. So adding 5 and subtracting 5 take away from each other. So all I have left on the left side is just x. Now what do I have left on the right side? Well, 17 minus 5, and what do we have there? 12. Okay, so now if we go back and check it, we can see that 12 plus 5 is equal to 17. All right, example 2. Same type of equation, except this time we're subtracting. Now the first thing that I'm going to do is I'm going to ask myself, what are they doing to k? What are they doing on that side? And you can plainly see they're subtracting 27. So now I'm going to ask myself, well, what's the inverse operation of subtracting 27? Well, it's to add 27. So I'm going to add 27 to both sides. Remember, what you do to one side, you have to do to the other side. So all that's left on the left side is k. And now, let's see, if the temperature is 38 degrees below zero and it goes up 27, it's still cold out. It's still in the negative degrees. And what would I have there? 11 degrees. So our answer is a negative 11. Now let's check it. Let's see if this makes sense. So supposedly k is a negative 11. So supposedly a negative 11 minus 27 is going to give me a negative 38. And let's see if that makes sense. Let's see if the temperature drops 11, then drops 20 more 7, or drops 27 more, then yeah, it's a negative 38. All right, example 3, subtraction, but a little bit more difficult because of the fractions. So the first thing I'm going to do in all these equations is, what are they doing to x? They're subtracting a half. So the opposite of subtracting a half would be to add a half to both sides. So I'm going to add 1/2 to both sides. Now this is where your calculators can come into play. If you know how to use that calculator and you're confident with doing that, great. Use that calculator. If you can't, then you just got to use the old paper and pencil approach. So let's see, if you subtract a half and add a half, they cancel out, and all I have left on the left side is x. Now I need to take 3/8 plus a half. So just quickly, I'm going to go through that. Find your common denominator. What's the smallest number that 2 and 8 go into? Well, 8. And then 8 times 1, 3 times 1, 2 times 4, 1 times 4. Now add, and I get 7/8. Now if you check this and you took 7/8 minus 1/2, okay, you're going to find out that you do get 3/8 then. Right, now what we just got done doing is using the inverse operations of addition and subtraction. Now we're going to get into the inverse operations of multiplication and division. So let's take a look at the first example, and I'm going to do the same thing. What are they doing to x? What operation's going on between that 3/5 and the x? Well, they're multiplying. So they're multiplying x by 3/5. Now what's the opposite or inverse operation of multiplying by 3/5? Well, we're going to divide by 3/5. So what I need to do here is divide both sides by 3/5. And we're getting away from using the division symbol. We're using the division bar, which is typically used in algebra, geometry, calculus, and so on. All right, now if I multiply by 3/5 and divide by 3/5, they cancel. All I have left is x on the left side. Now the algebra part of it, or I should say the arithmetic part of it, is to figure out what 27 divided by 3/5 is. Let's see, 27 divided by 3/5. Now here I'm using the old-fashioned division symbol just to show you or how your thinking process should be. So 27 times 5/3, right? Now I can cross cancel, divide them both by 3, and we get 3 times 5, or in other words 15. So supposedly if I check this, I should be able to take 3/5 times whatever x is, 15, and that should give me 27. Let's see, 5, so 3/5 times 15, and I'm just checking here to see, oops, I made one mistake, didn't I? Because right away when I started to check it, I could see that this wasn't going to work out. So if you go down below here, and I'll show you in red here what I did wrong, divide both these by 3, and that should be a 9 that's left down there, because 27 divided by 3 is 9. So 9 times 5 is 45. Now if I check this, and I'll erase this part up here, if I take 3/5 times x, that should give me 27. So in other words, 3/5 times 45 should give me the answer of 27. Let's see. Divide both these by 5, and 3 times 9 is 27. So it checks out. So it's good we checked that. All right, example 5, similar example. Let's take a look at what they're doing to y. What are they doing to y? They're multiplying by 3 1/5. So what are we going to do? We're going to do the opposite of that. We're going to divide by 3 1/5. So I'm going to divide both sides by 3 1/5. And if you multiply by 3 1/5 and divide by 3 1/5, they cancel out. And all you have left is y on the left side. Now, I need to figure out what 32 divided by 3 1/5 is. Or in other words, 32 divided by, how do you divide mixed numbers? Change them to improper fractions. So 5 times 3 is 15, add 1 is 16/5. I'm running out of room, so I'm going to put this up above what I just wrote. So you're going to take 32 times 5/16. Now I can divide both these by 16, leaves 2, and 2 times 5, I get 10. Now, I'm not going to take the time on the check on this one, but if you should be able to take 3 1/5 times 10 and get 32. Alright, I believe this is my last example. We'll see. In example 6, now what are they doing to x? They're dividing by 1/4. What's the opposite of dividing by 1/4? Well, multiply both sides by 1/4. So I'm going to multiply this side by 1/4, and I'm going to multiply this side by 1/4. Because we know that if we divide by 1/4 and multiply by 1/4, they cancel. Inverse operations cancel each other out. So you have x is equal to, now I'm multiplying here, so I can cross cancel. I divide them both by 4, and I get 5. Make a 5 a little better there. Okay, so I get an answer of 5. Now let's check this one. So supposedly 5 divided by 1/4 is going to give me 20. Well, let's try that. So 5 divided by 1/4. What's that mean? Let's see. That means 5 divided by 1/4. Or in other words, 5 times 4/1, which is 20. So it checks. Okay, now this is the last example. Now let's go through this one. What are they doing to x? They're dividing by 2 1/4. What's the opposite of dividing by 2 1/4? Well, we're going to multiply both sides by 2 1/4. So I'm going to have to squeeze that in over here. So I'm going to multiply both sides by 2 1/4. They cancel, because if you divide by 2 1/4, multiply by 2 1/4, they cancel. What's 5 times 2 1/4? Well, let's see. How do I multiply mixed numbers? You change them to impropers. 4 times 2 is 8, plus 1 is 9/4. And let's see, 4 times 2 is 8, plus 1 is 9, so that's right. Now there's nothing to cross cancel, so I just multiply across, and I get 45/4. And you can leave your answer like that. Can you divide 45 and 4 by anything? Answer's no. If you want to write it as a mixed number, you can. 4 times 10, let's see, 4 times 11, so 11 and 1/4, right? Would be the same thing as 45/4. Let's check that. 4 times 11 is 44, plus 1, 45/4. Now, I'd like you to do this check on your own. See if 11, and really I'd use 45/4, I just leave it like that. See if 45/4 divided by 2 1/4 does give you 5, and it should. So the basis of this lesson, which is a combination of 2 lessons, is solving equations by the inverse operations of addition, subtraction, multiplication, and division.